can see all these lines in this airport converging on one point, and that point that they converge to is called the vanishing point. This point right here is the vanishing point. And as you proceed along the lines toward the vanishing point, objects appear to get smaller. Let's look at the people in this image, who are all relatively the same size. As you can see, as we move into the distance toward the vanishing point, the size of the people decrease considerably. This man and this man, if they were standing next to each other, they're all the same size. But as you can see, they appear to get smaller and smaller as they move into the vanishing point. In other words, they're all going to eventually vanish also. Now let's look at this building outside. At first glance, you wouldn't guess that all these lines point to the same spot, but they in fact do. We'll draw these lines along the side of the building and follow these lines, and you can see that all of these lines point to one spot, the vanishing point. Even up here in these towers, just check this line here, from here to the vanishing point. It follows the lines. Now let's check the sidewalk from this point to there, and sure enough, the line follows the vanishing point. Now you'll also notice that the vertical lines on the building are perfectly plumb. That means they go straight up. Even though the lines on the side of the building are pointing toward the vanishing point, the vertical lines are still perfectly vertical or plumb. So the vertical lines in a vanishing point perspective are not distorted. Now the vanishing point is on the horizon. This line right here is the horizon. This is what we call the true horizon. Now the visible horizon is where the trees meet the sky up here, but the true horizon is at eye level when you're looking at an object or an image. I'll show you.
Geometry tells us that 3 dimensions suffice to describe the shape of any solid and the locations of objects relative to one another at any given moment. If changes in shape and location are also to be considered, the dimension of time must be added to the 3 dimensions of space. Psychologically, we can say that although we move freely in space and time, from the beginning of consciousness, the artist's active grasp of these dimensions develops step by step, in accordance with the law of differentiation. At the stage of the first dimension, spatial conception is limited to a linear track. There is no specification of shape. Disembodied entities, defined only by their relative location, can be conceived in terms of their distance, their relative speed, and the difference between 2 directions, coming and going. A mind limited to this elementary conception of space would be primitive indeed. It would apprehend no more than what we can perceive going on behind a narrow slot. A 2-dimensional conception brings 2 great enrichments. First, it offers extension in space, and therefore the varieties of size and shape. Small things and large things, round and angular, and the most irregular ones. Second, it adds to mere distance the differences in direction and orientation. Shapes can be distinguished according to the many possible directions they point in, and their placement in relation to one another can be endlessly varied. Motion in the whole range of directions can now be conceived, as can the curves an imaginative skater might execute. 3-dimensional space, finally, offers complete freedom, shape extending in any perceivable direction, unlimited arrangement of objects, and the total mobility of a swallow. Beyond these three special dimensions, visual imagery cannot reach. The range can be extended only by intellectual construction.